Okay, hello friends. This is Seth Itzkan of Soil4Climate, and welcome. Hello friends. This is Seth Itzkan. Okay, hang on one second, please. Okay, this is Seth Itzkan of Soil4Climate, and welcome everybody to today's webinar on regenerative grazing. We're very happy to have you all. We have a great lineup, and this really is going to be an exceptional program. To kick things off, our colleague organization 4p1000, Paul Liu, the founder and executive director of that organization, will be making some introductory comments, and then I will make some more comments, and then we'll get started with our program. Paul, take it away.
Thank you very much, Seth. Hello to everybody. I'm very pleased to be with you today. I'm Paul Liu. I am the Executive Secretary of the 4p1000 initiative. So welcome to this webinar proposed by Soil4Climate, accompanied by the 4p1000 initiative. I apologize in advance for not being able to stay for the entire webinar, but to be completely transparent with you, I'm in Montreal at the CDB COP15, and I have some other commitment ahead of me, but I wanted to be with you at the beginning of this very important webinar. The issue of livestock farming is still a very divisive issue. Livestock farming is still because it fits vision that seems difficult to reconcile with respect to animal products, and particularly ruminant farming. Unfortunately, there is often an amalgam between this intensive feedlot farming of North America and the rest of the more extensive farming using permanent pasture. It is important to talk about the reality of the result of properly managed ruminant farms that have a positive impact of greenhouse gas emission through carbon sequestration, water consumption, biodiversity development, and soil health. The objective of this webinar is to provide a more positive and realistic view of the impact of ruminant farming on climate change and biodiversity issues, particularly soil health. I wish you an excellent webinar and moderated by Seth. And Seth, I give you the floor back, and have a good webinar to all. Bye.
Paul, thank you very much for those comments. It is an honor for Soil4Climate to be associated with the 4p1000 organization. And just some background for friends, this is the first time that Soil4Climate and 4p1000 have co-hosted an event together. So Paul, thank you very much. Let me just also make some other just sort of general comments. This is being recorded on the Zoom cloud, and it will be, uploaded to YouTube as soon as possible. People are asked to ask questions in the Q&A section of your Zoom app there. The chat space is open, and you can chat as much as you want. But if you have a particular question, we ask that you ask it there. Otherwise, it will just get lost in all the chat traffic. Just a few more introductory comments. Today's program is extraordinary. Let me just sort of read the title again. Regenerative grazing is a soil, climate, and livelihood solution, the science, practice, and policy. And the three things there, first of all, regenerative grazing is the theme, but soil, climate, and livelihood solution, it's really those 3 points are essential. And then the science, practice, and policy. And each of our speakers today is really going to be presenting what I refer to as precedent-setting research, or breakthroughs in excuse me, in each of these areas. For example, on the science side, Dr. David Johnson will be talking about the research that he's done that shows how the soil biology is improving with regenerative grazing, as well as the forage, so the amount of plants, as well, and this is totally breakthrough science. I don't think anyone else has shown this before, the respiration of the soil itself. So the amount of CO2 coming out of the soil, the soil breathes, is itself coming down. So the CO2 from the soil is also coming down. And as far as I know, He's the first person who has measured that and included that in peer-reviewed research. Precious Piri, who has been a practitioner in holistic management and a trainer for almost 20 years, is at the cutting edge of having this be a communal event. So where you have multiple stakeholders coming together, in this case, communities with livestock, creating what's called a communal herd. And she'll be talking about the livelihoods aspects of this, how people's lives are actually impacted. And that includes the economics as well. We could make economics sort of a separate category, but it's embodied in the livelihoods. And then on the policy side, Dr. Leanne Winowicki is going to be talking about the soil health resolution. And this is a high-level resolution to get nation states that are participating in the COP, the coalition of parties for the UN climate conference, to include soil health in their nationally determined contributions. That's precedent setting, because as you know, the history of climate change conferencing has been about reducing emissions, as it must be, of course. So the focus has always been on energy, transportation, buildings. Those are the top three. But now we're trying to get a focus on soil health itself, and Dr. Leanne Winowicki is leading the charge for that. So you have three sort of precedent-setting themes here. One is the science, the other is the communal aspect of it, the livelihoods, and then there's the policy that Dr. Winowicki is bringing. So I will now make my introduction for Dr. Johnson, and then Dr. Johnson, you'll take it away. Yes? Everyone agrees with that format? All right, I'm just going to read a short paragraph introduction. I'll do this for each of the speakers, just so the introduction is done properly and is part of the recording. Dr. Johnson is a molecular biologist at New Mexico State University and a collaborating scientist with Arizona State University, Texas A&M, Michigan State University, and the United States Department of Agriculture's Natural Resources Conservation Service. Dr. Johnson and his wife, Hui-Chun Su Johnson, are the inventors of the Johnson-Su Composting Bioreactor and developers of biologically enhanced agricultural management, also known as BEAM. Dr. Johnson's most recent publication on adaptive multi-paddock, also known as AMP grazing, is a benchmark in the peer-reviewed analysis of regenerative grazing to build soil carbon and other soil health indicators, such as fungal to bacterial ratios. So, Dr. Johnson, the floor is yours. Please take it away.
Thank you, Seth. You can hear me, right?
Mm-hmm.
Okay, let me get rid of this. Thank you again, Seth. So we've been conducting research on a biologically enhanced agricultural management, or BEAM approach, as you were saying, to regenerate the diversity of life on our soils, helping to restore soil fertility on farms and ranches and benefit our environment and climate. Oh, I'm gonna have to reload, it's locked up. Microbes have been the dominant life form for almost 85% of the time that this planet has been in existence. And they have shaped every facet of the biological development for the last 4.2 billion years. We need to better understand that microbes are the backbone of every organism and ecosystem on this planet. No organism or biological system can survive without its resident microbiome. To that end, we participated in a complete systems analysis of grazing lands organized by Peter Bick of Arizona State University, in association with 3 other universities and 3 environmental research organizations, looking at soil carbon, nitrogen, water holding capacity, greenhouse gas cycling, vegetation growth, soil microbiology, my research expertise, insect and bird populations, and farmer and animal well-being. Adaptive multi-paddock grazing, or AMP systems, were compared to continuous grazing ranches on 5 pairs of cross-the-fence neighboring AMP and continuous grazing farms in the southeastern U.S., ranging from Mississippi to Kentucky.
David, if I could interrupt for a second, your
Sure.
slides are not screen sharing.
Oh, okay.
So when you rebooted it, you forgot to reinitiate the screen share.
Let me get out of it and come back into it.
No worries. We actually started a little early. I wasn't going to introduce you until 12:15, so we're doing fine.
Okay. Are you seeing them now?
No, I'm not.
You
see at the bottom, screen share?
Yes. Okay, let me reboot that up then. There we go. Can you see them now?
Yes.
Okay. Oops, excuse me. So everything's visible now?
Yes.
Okay. Oh, now I'm not, it's not allowing me to go forward now. My apologies here. It's
okay. No
giving me a
worries.
little bit of fit here.
No worries. If you want to send those to me, right now via email.
Let me try one more time here.
All right. Sorry, folks. We'll get with you in a second.
So are you visible? Am I visible now?
Yes.
Okay. Oops. Again, visible?
Yes.
Okay. Well, I'm going to have to leave. Every time I try to clear that bar at the top, it locks me up.
Well, maybe just ignore the bar.
Yeah, I'll have to.
Just ignore it. Just go to the next slide. Yeah, let's not worry about it.
Okay. So AMP rangeland management mimics the grazing systems that nature began to develop about 53 million years ago on the Great Plains of North America. That's when ungulates, I've got one other issue that I've got to take care of before I can.
So whatever that bar is, let's just ignore it. It doesn't matter right now.
What I've got to do is,
you know, we see most of the slides. That's what matters.
Okay. Okay. So AMP rangeland management mimics the grazing systems that nature began to develop about 53 million years ago on the Great Plains of North America. That's when ungulates and grazers evolved along with the grasslands. They both appeared in the fossil record along the same time. The system nature developed on the Great Plains involved bison. The bison were kept in tight herds by predators. The predators moved bison around regularly, so they would only graze about 40% of the forage that was there. The other 60% of the forage was either trampled into the ground through the hoof action or provided nutrients for soil microbes or left standing to provide leaf area for photosynthesis. The bison would deposit their dung, their urine, and their saliva. The dung would be rolled up into small balls by dung beetles and placed underground. Basically, it would be composted in place, perfect temperature, moisture, content, soil microbiota, and worm communities, allowing soil microbes to flourish. What was going on as the bison moved was a microbiological inoculation event that swept across the prairies as the bison herds crossed. In our comparison between AMP and continuous grazing, the first thing we observed was a 2.16 times increase in carrying capacity per animal units per hectare, indicating that adoption of AMP systems effectively supported more grazing animals and produced more revenue for ranchers when compared to continuous grazing. The next metric we measured was standing crop biomass, or forage, grown from January to early June in AMP and continuously grazed farms. AMP systems produced 46% more standing crop biomass in this time period, helping to better understand the increase in carrying capacity of AMP systems. Another study on these same farm payers concluded that annual standing crop biomass was 300% higher on AMP ranches than on continuously grazed ranches. AMP systems also demonstrated 20.6 higher soil organic carbon content in the top 15 centimeters of the soil when compared to continuously grazed farm management. We also measured the CO2 respired from the AMP and continuously grazed soils. A 19.52% reduction in soil respiration was observed in the AMP systems when compared to continuous systems, even when AMP systems as a whole had 20% greater soil organic carbon and 50% more by microbial biomass that could have respired that carbon. Just a quick refresher, nature spent the last 4.2 billion years developing systems that continuously evolved and adapted towards improving efficiency of the capture, storage, and utilization of energy captured from the sun through photosynthesis. Nature accomplished this by creating different levels of biological organization to facilitate this flow of energy. The soil food web is such a system. It is composed of different community members and their trophic levels or functions in a soil microbiological profile. As you move up the trophic levels or the food chain, energy is converted, nitrogen and other nutrients are released at each trophic level, promoting nutrient release, capture, and cycling. We analyzed the soil food web in AMP and continuously grazed systems. On these graphs, the y-axis or the vertical axis represent the forage production of the AMP and continuous grazed farms as grams dry biomass per square meter. The x-axis or the horizontal axis of each graph represent biomass of fungi and bacteria on the top two graphs, and fungal to bacterial ratio and the soil food web proxy on the bottom two graphs. On the left top graph, increase in fungal biomass in AMP systems, the green circles, were positively correlated to increases in standing crop biomass. And on the right top graph, bacterial biomass was negatively correlated to increases in standing crop biomasses. Simply put, increases in fungal mass and a decrease in bacterial mass in AMP soils was closely tied to increasing forage production. Continuously grazed systems, the yellow triangles, in both comparisons demonstrated no correlation, and the continuously grazed systems appeared chaotic. Similar observations were seen on the lower two graphs, where increase in fungal to bacterial ratios on the bottom left graph and increases in community members in the soil food web total biomass, or the proxy, on the bottom right graph correlated well with standing crop biomass increases in AMP systems, the green circles. And yet again, there is no such correlation with continuous grazing, the yellow triangles, only disorder. The next observation that correlated well with forage productivity was nutrient mobilization through the influence of the predator-prey relationships between the two rangeland management approaches. The graph of ant systems on the left-hand side demonstrate increases in nutrient mobilization for improving forage production on the bottom x-axis. As protozoa populations, the predators increased, the pink triangles, and the bacterial community biomass, the blue circles, or the prey, decreased. In contrast, the graph on the right-hand side is the continuous grazing systems, show that predator-prey relationships were broken. No correlation exists between the bacterial populations in the blue circles, the protozoa population in the pink triangle, and standing crop biomass. Again, complete disorder. When you look at the influence of ant systems on forage biomass, soil organic carbon, and soil CO2 respiration, and tally the impact, you see that they have significant influence on atmospheric CO2. If ant systems were adopted on the 1.25 billion hectares of savannas and grasslands, forage biomass increases would promote an extra 9.82 billion tons of CO2 pulled from the atmosphere into plant biomass. Soil organic carbon increases would promote 2.34 billion tons of atmospheric CO2 per year stored in the soil. In addition, ant systems reduce the flow of soil respiration by 6.6 billion tons of CO2 per year when compared to continuously grazed systems. Collectively, these increases in the capture, storage, and utilization of energy from the sun and reduced respiration of CO2 promoted a more efficient agro-ecosystem that had the ability to draw down 18.8 tons of CO2 per year, or about half of our current fossil fuel emissions. The AMP approach is not limited to success in only temperate grasslands, as it also works in desert environments. Alejandro Carrillo is a rancher in the Chihuahua Desert of northern Mexico. Pastures he is currently ranching had been desertified from a century of previous mismanagement excuse me, and overgrazing. As you can see in the picture, it took over 250 acres to support one cow on his pastures. Before the 1800s, this area was a natural grassland and had grasses belly high to a horse, according to historical accounts. This area also has limited annual rainfall with an average of 7 to 8 inches of rain per year. Today, with proper grazing management, Alejandro has reestablished the native grasslands. His grazing practices have turned the desert back into a grassland, significantly increasing photosynthetic capacity and forage production potential on the soils on his range. It takes only 25 acres to support one cow. This regeneration of a grassland in the middle of a desert reveals the potential that when you work with nature, mimicking the systems she developed, the restoration of almost any ecosystem or environment is possible. Now, if you're farming cropland and have destroyed your soil microbiome from implementing heavy tillage and application of fertilizers and pesticides, and do not have or want cattle in your operation, you will need a mechanism to restore the soil microbiome. My wife, Hui-Chun, and I developed a no-turn composting process that mimics nature, and it appears that you can regenerate a healthy soil microbiome with a vermicompost product made in this bioreactor. This composting process results in a fungal-dominant, biologically diverse compost that is able to help restore the population, structure, diversity, and biological functionality of cropland soils. The product of one of these bioreactors can inoculate 350 acres of land, making it practical for large farming operations to adopt. The cost of the material and application average from 50 cents to $1 per acre, making it affordable to implement. The compost is applied at 2 pounds per acre rate. Mixed as an extract, 2 pounds compost per 20 gallons of water, injected into the furrow at planting to ensure its seed, soil, and microbiome extract content. We observed over double the plant growth on the test on the right-hand side of the picture in small plot trials when the extract is in contact with the seed in the furrow when compared to when it was sprayed on the top of the soil, the image on the left. We are currently demonstrating these potentials in a project working with Stella McCartney, a fashion designer in England, and Soktas, a cotton and fiber production operation in Turkey, implementing a biologically enhanced agricultural management or BEAM approach, applying an extractive compost and adopting management protocols that always have a living root in the soil. The improvements we are observing in their cotton production systems are an 85% reduction in nitrogen fertilizer use, 100% reduction in phosphorus use, 100% reduction in herbicide applications, 56% reduction in insecticide applications, 61% reduction in diesel fuel, and a 35% reduction in water application. In addition to all of these benefits, in using cover crops to commodity crops, we're capturing 14.37 tons of CO2 per hectare per year as soil organic carbon, accompanied by 293 kilograms of nitrogen per hectare, over and above the nitrogen supplied by the soil microbiome to supply nitrogen for the cotton crop. We are in the regeneration phase of restoring soil microbiome population structure, diversity, and biological functionality. So cotton productivity was about 17.5% lower than the conventional cotton production. However, the bean cotton crops promoted $890 to $1,100 more profit per acre for the farmer than the conventional approaches when you consider the reduction in input costs. The results of using the Johnson-Su compost is also showing promise in Montana with a farmer, Corey Miller, and his father-in-law, Kevin Lackey. They seeded a 40-acre plot on their farm with cereal rye, and on one pass using a no-till drill, they applied the compost as an extract in furrow when planting the cereal rye. The part of the plot without compost extract produced 8 to 12-inch high cereal rye. The plot with the compost extract produced cereal rye plants 4 to 5 feet tall. You can all see the difference in the plant root ball in the picture on the right. I highly recommend you download the video in this link at the bottom. The video was unsolicited by us. Corey just produced and released this video to help other farmers. It's a superb video, how to implement compost on a large scale. This is another unsolicited video on YouTube produced by Jay Young of Young Red Angus in Greeley County, Kansas. He's using the Johnson-Su compost in his corn production system. Corn uses more nitrogen than any other crop on the planet, but you can see he produced 200 bushels per acre of corn with no nitrogen and no phosphorus, only compost extract injected into the furrow at planting. In 2021, he repeated the same protocol and produced 207 bushel per acre corn, saving $173,000 in input costs. The link at the bottom is another great video to watch to better understand the benefits and processes of using the Johnson-Su compost. CO2 is the second most important molecule on the planet next to water. It is the main component in the planet's energy capture mechanisms through photosynthesis, producing sugars that provide energy and carbon skeletons for manufacturing the structural and metabolic proteins for all life on this planet. Most scientists and industry are trying to permanently store CO2 as a static, non-reactive, amorphous element. We would be better served to work with and mimic nature's design and using the characteristics of carbon dioxide as a living, functioning energy and nutrient cycling entity. Restoration of the soil microbiome increases elemental nutrients and nitrogen flowing back to the plant, increasing photosynthetic capacity, and this in turn provides more photosynthetic flow to the soil microbiome, increasing soil microbiome population and activity, creating more extraction, elemental nutrients, and nitrogen fixation. And as we are observing in our research, a significant reduction in soil respiration with each iteration, building on the previous in a positive feedback loop. There is a limit to the amount of carbon that soils can contain, and that is approximately 7 to 8% soil organic carbon. However, if we look to the past, we observe older carbon at depth, the green bars, and the younger carbon on the top, the blue bars. So nature also builds soil carbon layer by layer in biologically active systems like those in the bean plot. These new soil layers continue to build year after year, increasing topsoil depth, offering no limit to the amount of soil carbon as we improve soil health. Adding cover crops to the bean approach offers another opportunity for improving photosynthetic capacity of the system. Cover crops are planted in the cooler months of the year, and commodity crops cannot grow. When using the right variety of seed, they take advantage of winter rains and make significant accretion of plant biomass to be rolled down before commodity crops are planted. The cover crop in Turkey added over 10 tons of dry biomass per hectare, a crop that has more total biomass than the cotton crop that followed. This promoted another 21.8 tons of CO2 drawn down from the atmosphere. Besides for fixing carbon as plant biomass, this cover crop offered protection for the soil from the sun and heat, nutrient and energy for the microbiome and future crops as the biomass degrades, a microclimate of increased soil water holding capacity, and slightly elevated CO2 within plant canopy to produce improved plant growth, habitat for beneficial insects, and the deposition of a thin layer of organic carbon-rich soil, rebuilding soil depth year after year at approximately 1 ton soil carbon per hectare per year. We'll look at the magnitude of CO2 emissions resulting from fossil fuel emissions and compare it to the global influence of soil microbes, ocean microbes, and plant respiration. Fossil fuel emissions amount to only 3% of that total. We have the choice of making a significant change in a small component at tremendous societal expense and sacrifice, or make small improvements in the significantly larger components with no cost for our side, while producing more nutrient-rich food, restoring fertility to our soils, reducing atmospheric CO2 concentrations, and helping farmers and ranchers become more profitable. The large components I'm referring to are the 1.36 billion hectares of temperate grasslands and the 1.25 billion hectares of farmland on this planet. These lands are amenable to management improvements and offer the most potential for short and long-term beneficial management protocols. We are vastly underestimating the potential of farming and ranching systems to absorb and utilize living carbon from the atmosphere. Restoring the population, structure, diversity, and biological functionality of the soil microbiome offers significant opportunity and potential for offsetting fossil fuel CO2 emissions. Adoption of AMP management on the 1.25 billion hectares of temperate grasslands would offer 18.82 tons of CO2 offsets per year. And adoption of BEAM on 1.36 billion hectares of the world's cropland would offer 42.9 gigatons of CO2 offsets per year. Together, the CO2 offsets potential of these two systems would promote 61.72 gigatons of CO2 per year, or approximately 1.6 times the annual anthropogenic CO2 emissions. So this is all about energy capture and utilization. Much as our own civilization, our societies are completely dependent on the availability and flow of energy. Without it, the system collapses. The regeneration of soil microbiomes and farming and grazing agri-ecosystems will help farmers and ranchers to be more productive and profitable, in turn restore rural economies. This approach will also address multiple complex societal issues while providing a logical, practical, and profitable vehicle for reducing atmospheric CO2 concentrations. All we have to do is align ourselves with nature. Thank you.
Dr. Johnson, thank you very much.
More than welcome.
Extraordinary presentation. Thank you very much. There were a lot of great questions that came in. And if you look at the Q&A thing at the bottom of your Zoom screen there, you can see them. We don't have time for you to start answering them now, but okay. That is if you wanted to do it via video, but you can type the answers to the questions and everyone will see your answer there, okay? So you can start doing that. What I want to bring people's attention to right now is in Dr. Johnson's summary, his second to last slide, he said that the total drawdown capacity from these different methods is 1.6 times the anthropogenic emissions. That means we can actually draw down more than we're emitting. That's an important takeaway, folks. Now, no one is suggesting that we should stop emitting. No one is suggesting that. But the point is the potential drawdown is huge, and we have to start building out that capacity, both in terms of regenerative grazing and the cover cropping and the biologically enhanced agricultural management. We'll come back with more questions for you in a minute, but right now I want to turn to our second speaker, Precious Piri. Precious, are you ready? If not, that's no worries. We can come back to you later. Okay, so you'll need to unmute. I will just read a quick introduction for you. Precious Piri is coordinator at Igugu Trust and Regeneration International and was for 16 years program manager at the Africa Center for Holistic Management in Zimbabwe. This is the birthplace of holistic management and the first Savory Institute hub. Precious has coordinated training in regenerative grazing and holistic decision-making with agricultural and pastoral communities in Zambia, Zimbabwe, and Kenya. She has helped guide and been witness to extensive improvements in livelihoods for these populations who are fully dependent on land-based resources and industries. And just really quick, Precious, before you come on, I just want to tell people who have joined since we started, there are sort of three domains that we're looking at here: science, policy, and practice. So David Johnson just did science, and under practice also livelihoods. So David Johnson just did science. Precious is going to look at the livelihoods impact of this, and then Dr. Winowicki will look at policy after Precious. Okay, Precious, go ahead, take it away.
Thank you, Seth, and also thank you to Dr. Johnson for beautiful background and really grounding on the scientific aspects and the data. And we really appreciate all your extensive work. And hi, everyone. Thank you for the gift of your time. It's evening, my time here in Zimbabwe. I don't know what time it is where you are, but I hope you're having a wonderful day and evening. So my part is to share about practice. So I'll mostly be just sharing about the experiences and what I see as potential, and what we're learning is potential for regenerating the broader landscapes. And in this segment, using regenerative grazing. My experience is with the holistic plant grazing, which is under holistic management. And I am an educator and trainer and facilitator with communities, as well as accredited with Savory as facilitator of the communal curriculum of holistic management. So, which really entails breaking down information to reach out as a way of movement building. I feel like this conference is very important, and thank you to Seth, Soil4Climate and 4p1000, your teams. This webinar is really, it's one of the few that I've gone to with the three important pillars of this work really merged together. The science, the practice, and policy. So practice and science can really influence policy to help make decisions. So this is why the regenerative framework is very important in this sense. So I'm just going to go through really quickly. I think Seth introduced me, but I'll just go straight to the presentation and rather quickly. Just to bring out the impacts of land degradation. So I'll give an experience of the communities that I work with here back home in Zimbabwe. So we face these always extreme, really. And I'm bringing three pictures here. One on the left, my left, is an old, beautiful man who is in a flood. And the picture to the left and the one in the middle were literally happening in the same season in my country, Zimbabwe. The Eastern Highlands were flooding and, of course, losing crops and food and life and stability. And then Western Zimbabwe, where I am, we were in the midst of one of our worst droughts, including farming practices that are not ecologically viable. So same rainfall season, same country, different impacts. And then the right one is the beautiful people of Samburu in northern Kenya. That's where I've also done some work in rangelands management, where they have vast lands that have been degrading. But, I think our role is to bring the hope and, the second and third and fourth chances that we actually have, if only we really learned and read what our land needs and we utilize the relevant tools. So this was just for background and not to scare or bring in any sadness, but I was just bringing in the context which this work happens. And as I said earlier, we train using holistic management, which maybe I may take an opportunity here to say it is a simple decision-making framework that helps us manage the web of ecological, economic, and social complexities. So we use tools and solutions that are relevant and communally reliable, and people are aware of them. But I think it's just an issue of transformational work and paradigm shift for us to realize that we have all the tools already. And just a few words on that slide to say that the designs that we use when we work with communities are context specific, and they bring out the essence of each place. And as such, I'm a big advocate of demystifying best practices, because there's no one size fits all solutions. They differ in each area. And in this case, I'm bringing the story of holistic plant grazing. And thankfully, Dr. Johnson did a lot on the scientific and the figures, and I can probably just share some pictures and take you on a journey. And so the three pillars that I've seen that this work helps when we work with communities, it's really improving ecosystem processes, that is the functionality of the land and all the ecological services that are found in each area, that is the water cycle, how the energy flows, how effective is our solar energy flow and mineral cycling. And I mean, I'm sure you guys are used to most of these things, including the dynamics and the biodiversity in the environment. And then strengthening economic drivers. Most of the communities that I work with are actually agro-pastoral farmers. And so that means all our livelihoods are really dependent on the farming of livestock and cropping. And then thriving and stable economic communities, which is socially and culturally. Okay, I'm not going to talk about this slide because I think Dr. Johnson did much more work on that. I'll just dive into the tools that we use that are mimicking natural patterns. And just as a matter of mention, holistic management is really built from the body of knowledge, which has been driven or steered by Alan Savory. And he learned so much when he was working in Africa as an ecologist. He's a Zimbabwean. And here in Zimbabwe, right next door to where I live, is one of the most beautiful places you ever land on earth, the Africa Center for Holistic Management, where they have practiced and actually seen results of holistic plant grazing and land management, mostly learning from just how the wild, large herbivores behaved when they were being pushed around in their grazing by pack hunting animals. So this changed their behavior. They always grouped together, dunging and urinating because they were jittery and afraid. And because they've dunged and urinated, they just had to keep moving. And so based on these principles, in the holistic management framework, we have the tools of biological animals, which is any form of livestock, but in this case, you're seeing cattle and people who are heading and learning together with their land. I think you can just see from this photo here, animal impact. When animals have moved, they do two things. They graze, and which is the actual act of eating the grass. And then they also trample and dung and urinate, which is massive interaction with the landscape. And in landscapes like ours, where you're talking about thousands of hectares, it's hard to say you will put compost in one end of 2,000 hectares in a community. You are better off using available tools that have obviously shown that our lands have evolved with these. My story today is bringing lots of stories from just the communities. We work a lot with women, men, traditional leaders, the youths who are also herders, and old men who also herd their own animals, because this is one important aspect in these communities. So we create abundance and by harvesting on the excitement of what is possible. So we do lots of learning, sometimes from the Africa Center and other partners who have started already ahead of us. So when when you bring people together and there's that learning, that excitement happens, and then each one goes to their own community to then draw what can be done. These are community-led efforts and inspired by strong leadership. So as you can see in this photo, let's see, I don't know if you guys can, yeah, I'm sure you can see. There is that man with a green mask there. Oh, I see that I mistakenly stopped my video. Okay. He's an incredible leader. He's actually a man right under the chief here where I work in the Wange communal lands. He's if our leaders can really see the vision of what's possible with our landscape, they tend to lead from the front, and people really sign up and join in the processes of healing the land and bringing back that health that we've been looking for. But what I will share is that this is not an easy walk in the park. So this work is as scientific as much as is a social issue. So it needs a lot of interaction with the communities and bringing communities to that awareness. I think we need to regenerate beyond just our crop fields or gardens, because our whole landscape is such a potential place to capture water and change the trajectory of our lives completely. So this is just a picture of a grazing planning chart. We're in the growing season now, so we just recently created plans like this. So now we have 5 that we're working with here, 5 clusters, and I think you can see on here some livestock numbers of how many communities are now practicing. Just here in Vic Falls where I work, you have 1, 2, 3, 4, 5 communities with different sizes of livestock, and over the years, the livestock numbers are added on because people see results, and we'll be sharing them later. And this is a recent heading team training that we did. We now have like 39 headers. So let's see. Okay, and a bit of a photo there on the progression of landscape regeneration. This is BH9 in one community called Ndlovu. You can, so it's 2 different seasons, but I'll show you where there is the same season and you can see the differences. But for us, this was one of the most important turning points, because here we got to invite even the chief to come and see what is truly possible in our landscape, and by just using the animal hooves and heading. And so there's a lot of training that goes in here, where we train headers how to manage livestock and also carry on reading the land, because really the herding is an art and a skill. And we have the Africa Center for Holistic Management for our herders to go and get recharged and inspired. And sometimes you see lots of growth even in the worst drought. By drought, I mean in the worst rainfall amounts. So this is in Zambia, sent to me by our friends. It's Grassroots Trust. They also have landscape regeneration using livestock. And you can see they started 5 years ago with just 60 cattle. But now this has improved to like over 500. And I feel like it's important to have all these stories that are scattered across different regions, especially for communally owned lands. And maybe just to give others a bit of perspective and background, these are communally owned spaces that belong to the state and are under the guidance and leadership of traditional leaders. And so everyone has a right to this piece of land. And so for Zambia they've started off with 60 cattle and now 500, that's a lot of social organizing and building trust and proving that there is lots of potential. So, and then with communities, this is all part of building up socially, because I think communities also have to have ecological literacy of why we are in the problems that we are in, and so that they know how to really address root causes. And then a few pictures again from the last growing season, 2022. So we're waiting for, so this was 2021, 2022. Now we are in 2022 going into 2023. You can imagine, I think there's a time when Dr. Johnson was talking about a number of how many hectares or how many acres he needed to feed one animal. I think he said 250. And so with communities, sometimes we may not be well equipped to do calculations, but we use different methods of just tapping into the knowledge of the community to say, how much land do you think can feed one animal unit? And in our case, one animal unit is a cow. And so you do like a square and people stand in those posts, and then we keep moving backwards if you feel like no animal can be fed fully in one day here. And so to the left, in the poorly managed rangeland, this is the same community. There's one land that they protected so that they will see, they get to see what differences they can make. On the left here, it was literally 17 meters by 18 meters. I know maybe this may be a problem because we use meters here. So 17 meters by 18 meters could feed one cow. And then to the right, in the well-managed land in the growing season, here they just say 4 meters by 5 meters. It's so little. You need such a little piece of land to take care of your animals. And then from that, you then discuss, so what does this mean? And you know, this is knowledge that can't be traded for anything. And this is what the communities have always had, but maybe it's just needed rekindling. And look at the same landscape in the non-growing season. Immediately, this one is now bare and suffering and cannot carry any more animals for the community. And then look at the one that they really used a properly managed grazing plan, and they still had enough forage. And in the years, you would have animals dying from famine, but then here, we literally pushed, it's now growing season again. We didn't lose anything. And then lots of leadership support and skills to share the story of land. So now we've had lots of growth in people managing to tell what we did. And the tall man here at the center with the tie is actually the chief of this land. And one of my privileges has been to have him to actually come and see what we've done. And it really helps because everyone gets inspired. I mean, so this is just a photo to show that I think in landscape regeneration, using holistic plant grazing, we really work together to bring in the spaces for relationship building with communities. So between people and then between people and their surroundings. So here we had a big celebration this year of seeds. I'll share just a little bit in a bit. And then the community decided to take this beautiful photo with leaders in the middle and then supported by the rest of the community. This was a gathering of about 185 people, and just it was just so beautiful. And for me, this photo really now means so much more than just a picture. And then soil health. Is the essence of food and seed sovereignty. So we use, again, the tool of livestock to improve our soil and soil nutrition. So this is ecologically viable. And then farmers use this for planting. But here's another photo again, maybe on the far, at the top there, these soils are really sandy and really harsh. And sometimes farmers really, no matter how much fertilizer you put, though they do, you don't have a harvest. So we've spent a lot of time this year also hopping in and out of seed fairs across the country. That's creating social fabric across the country. So here, this was a meeting of sharing seeds. The lady in the middle there is actually the agricultural extension officer, which means now we're also partnering with government. They were now coming to share seeds in this one village. Okay. Let's look at the differences in the soil now. What happens? Same soil, same everything, just different tools of improving soil fertility and quality. And you can tell even from the pictures, same cropping season and just different methods and techniques of using the seeds, you have seeds that cover the soil, and then you have standing mixed grains. So here we have pumpkins, we have cowpeas, which would be nitrogen fixing, and then small grains or our traditional grains, and then some maize. And then a farmer here at the top would harvest 2 to 3 times more than the farmer at the bottom. And sometimes the farmer at the bottom wouldn't even have a single harvest. And so now we literally are under pressure. At first, it was a high road, because here we also work with people who are in the frontiers of the national parks. And so there's a bit of tension when livestock are attacked by lions. So, but I think people have tested to see that the enclosures and the kraals that we use for their animals to sleep in the crop fields, they actually also prevent or lessen the risk of animals being attacked.
Excuse me, Precious.
Yeah.
This is profoundly wonderful, of course, but we do need to wrap up soon. So
yeah, sure, I'm almost done. Just one or 2 minutes, yeah. So these are the stats that I was giving. So it's really abundance and resiliency. And then this is a photo that I spoke about. We had some seed fair. So they bring all the seeds that they've planted ecologically and ways of preserving these seeds, and then also create a space for sharing the seeds. So yeah, that's it. I was really done. So thank you. I hope this was helpful and a quick story just from my end. Thank you.
Precious, thank you so much. I want to give you an ovation for that. It really helps bring it home, to see how people's lives are improved. And that was your charge to talk about the livelihoods aspect of this. Thank you so much. And it really isn't fair to you or to any of our panelists just to expect you to do all this in 15 minutes. But this is what we got. So let's, so Precious, also look in the Q&A area here and just type answers while Lee does her presentation. Let me read the introduction for Dr. Leanne Winowicki now. Dr. Leanne Winowicki is Soil and Land Health Research Lead at World Agroforestry, Lead for the Coalition of Action for Soil Health, and Lead for the Soil Health Resolution. The Coalition of Action for Soil Health was co-host at the first ever UNFCCC COP Food Systems Pavilion. I'm happy to say I was there recently in Sharm el-Sheikh, Egypt, and Lee and I met there. It was great. The Soil Health Resolution introduces soil health into UNFCCC deliberations. UNFCCC, by the way, folks, is sort of the overarching agency of the UN Climate Conference. It stands for the United Nations Framework Convention on Climate Change. Okay, it asks parties of the UNFCCC to include soil health in their nationally determined contributions, the NDCs, to meet the goals of the Paris Agreement. As a soil scientist, her research focuses on scaling farmer-centered landscape restoration, understanding drivers of degradation, and quantifying the impacts of land management and soil organic carbon. So Lee, take it away. The floor is yours.
Great. Thank you so much. And great to be here. Thank you for the opportunity. I'm Lee Winowicki. I'm a soil scientist. I'm based here in Nairobi. And today, I just cannot help but also talk about the importance about advances in soil and rangeland health monitoring and how this relates to the Coalition of Action for Soil Health. In case I lose someone, in case you fall asleep during my talk, here are the key messages. So just get these down and then, go back to having your coffee or tea. My first point is very much iterates what the previous speaker said, is that we can translate science into action. And in fact, science is critical to inform decisions, but also to change how we're managing the land. I hope I'll convince you that we, in fact, have the tools, the methods to track soil and rangeland health, as well as to understand the underlying processes of land degradation. Our research shows that through stewardship, and I think what Precious and the previous speakers spoke to was clear, we can improve soil and rangeland health through stewardship. And that it's very important that we encourage that these innovations are farmer-led, pastoral-led, and that each of these interventions must be tailored to meet the needs. And finally, I'll highlight the need for this public-private engagement to really scale soil health. And I'll finalize my talk on the Coalition of Action for Soil Health. So I think Precious showed some amazing photos. This is also from Zambia, just talking about how we are at a crossroads. Between 20 and 40% of the Earth's surface is degraded, negatively impacting livelihoods. We must take action now. And what I'll focus on is that we need targeted investments in soil health and rangeland health, and that these investments can include monitoring to help us prioritize actions, but also track changes over time. Everyone was very interested in the first presentation because it allowed some data for the difference between different grazing practices. These data and evidence are critically important, and we need these investments for combating climate change, to realize the SDGs, and also to scale ecosystem restoration. So I'm going to talk about one method that we've developed at eCraft, and it's called the LDSF, the Land Degradation Surveillance Framework. Why is this framework so powerful? Well, one is that we monitor all of these indicators on the right at the same georeference location. So that's rangeland module, tree density, diversity, degradation, hydrology, soil health, and we also categorize the land management. This allows us to conduct statistical analysis and produce maps of these indicators. So what's the second benefit of this method? Well, it's that it's been applied systematically across 43 countries. In rangeland systems, in forested systems, in agricultural systems. You can see Providence in Rwanda in the lower left. You can see my team in the lower right in Vietnam, looking at earthworms in India, rangelands in Lesotho, and then the clinometer use with our partners in Senegal. It's the same methodology, but across multiple projects, multiple donors. So this is, I think, Seth, this may look familiar to you. Anyone who wants to name that sacred mountain in the background of this photo here in northern Kenya, I'll let you put it in the chat. And you can see that we're trying here to do a rangeland health survey. And I hope what's really stark you can see is the amount of bare soil that's here. And anyone who's really familiar with Kenya can see this tree in the vertical shape is a native tree, but it also has some properties that are not beneficial when it dominates. So that's Acacia rufescens, and then to the left is the Commiphora. So why do I talk about this? Because this method looks at everything from the soil to the hydrology to the vegetation. And I thought it would be really interesting today to just go through some of these data that we have. And I really liked the focus on the bacterial fungi ratio. We also do that in our lab at eCraft, but today I'll talk about vegetation and how we can use this also as a key indicator. So in our rangeland health module, anyone who's really good at grasses can probably guess which grass is dominating in these photos here. We look at annual and perennial grasses, non-woody forbs, woody species, bare ground, and combine these with the LDSF indicators. So here's some photos. I think you can see me in a bright purple shirt down there doing some rangeland surveys. So what are some of the data? Anyone here from Kenya? This is a really exciting GCF project we have called Twende, and I hope people know what Twende means. It's like, let's go. And I think we're motivated by Precious and well, by both speakers that there's a lot we need to do. So I wanted to show these data from 3 sites. So we have the Laisamis site in the north, in Balambala and in Birikani. So this is the map in Kenya. where these three LDSF sites are. Now there's these three bar charts. And the bar chart on the left is the number of unique perennial grass species in each of these sites. So 100 square kilometer site. An LDSF site is 100 square kilometers. Now, you may think, oh, this Mbirikani site that has such a big bar chart, but in fact, we're only seeing 40 unique grass species in 100 square kilometers. Yes, it's higher than the other two sites, but in reality, this is a low number. Now, if we go to Forbes, so this is non-woody vegetation, we see Mbirikani also has higher, but around 60. We also looked at woody species. So we're comparing the species diversity across these three sites. And what will be interesting now is to focus on what is it that is making these differences? How is the grazing management? What are the restoration actions going on in these sites? But it's very important that we understand the baseline situation in terms of diversity. Now, I'm not happy to see that in Mbalambala, in Tana River, it's such low number of perennial grass species, 15, only 20 forbs, and higher woody species. And we can all have a long discussion, as Seth wants, about woody species encroachment. My second favorite thing is to really hone in on what are these grass species. So this is actually a conservation site in northern Kenya, in Lewa Conservancy, and you can see that Cenchrus stromenius is the dominant grass. Then we are followed by Sahima nervosum, Cynodon-dactylon, Chrysopogam plumilosus. This is such a cool grass. Anyone who likes grasses, it curls and it really specializes in the rocky outcrops. And you'll actually find wildlife tracking up to these rocky outcrops just to find this Chrysopogon because it's so nutritious. So I think it's really important that when we start doing these comparisons, we're looking at diversity of species across the vegetation structures. Now, let's talk about soil. So we heard some things about soil carbon, but why do we love soil carbon? And believe me, I hope I've convinced you that we need to monitor multiple indicators. But if you had to say, Lee, what's the one indicator of soil health that you can measure? We would say it's soil carbon. Why? Because it influences many other processes. In the Q&A, there were questions about carbon and water holding capacity. Spot on. Higher carbon, higher organic matter, higher capacity to hold water. It increases fertility and increases and influences land productivity. But why do we measure it? Because it responds to management. So if we poorly manage the land, we have lower soil carbon, of course, within the constraints, but we can actually increase soil carbon. And I'll give you a hint. This is my hand, my farm, my vegetables in my garden here in Kenya. We also love carbon because we can quantify it, we can map it, we can measure it. So what was the soil carbon in some of those sites that I've just shown you? If you don't like the colors, you can blame Tor Vaughan, who made this graph. I think these should be brown and orange, but that's okay. So my point here is just looking at box plots. We love box plots because they show variability. Now remember, the wider the box plot, the greater the variability in carbon. And the purple blue is topsoil and the green is subsoil. Remember, these data are from 100 square kilometer sites. So each topsoil is 160 plots of composite soil samples. So what is striking here? Well, the top and the bottom sites have very small box plots, very narrow. And this is low variability and also low carbon. And this is from 160 topsoil and 160 subsoil samples. So we're hoping now with some regenerative grazing practices, with some restoration, with some care of the soil and increasing soil cover, we can start increasing soil carbon. We see Mara North and lewa having higher carbon concentrations. But what also is interesting, of course, we see high in topsoil, but we also are seeing quite high carbon in subsoil. And that's a key takeaway message for grazing systems. We can store carbon deeper in the soil profile because of the nature of grasses, with their annual roots dying and contributing organic material every year. I have to show you maps. Of course, I have to show you maps. The government of Kenya has contracted C4E to produce soil organic carbon maps for 13 counties across Kenya to track how well their interventions are doing. So we produce these every year based on the LDSF to see if the intervention sites are increasing. That bright yellow spot, that's low carbon. The darker spots are higher carbon. So you can see in Makueni, Kitui, and Taita Taveta, where it's drylands. I think we heard Precious talk about sandy soils have lower carbon. So inherently, sandier soils store less carbon. Last slide on the maps is now how we can combine these data, carbon plus erosion maps, to prioritize restoration. So we've done this in Laikipia, which of course is a critically important rangeland and grazing area. In fact, I think the beef I ate tonight was from Laikipia. So we put all of these into dashboards so you can go to these links. I'll put them in the chat, interrogate, scrutinize, visualize, and explore these data. So now, how does this relate to cash? We saw a real need coming out of the UN Food Systems Summit to pull together groups like COP per Mill, Soil4Climate, and 112 others to really work to scale soil health globally. We realized there's implementation, monitoring, policy, and investment barriers that are constraining farmers from scaling healthy soil practices. We have 4 goals: integrate soil health into policy, expand on research and development, answer those key gaps, increase the number of land under healthy soil practices, and increase financial investments into soil health. We have over 110 partners, and we work in regional hubs. And we have really exciting updates. So we have monthly newsletters, we have engagement survey. If you go on our website, you can look at the flagship initiatives. This Drylands Transform is a rangeland health using livestock cafes in Uganda and northern Kenya. We also just got on board the British Soil Science Society, and I hope everyone is aware of the Living Soils workshop sponsored by Moet Hennessy. And what did we do at COP27? We hosted the first ever Soil Health Day in the Food Systems Pavilion. This is amazing. And our big highlight was this plenary session, which had not even standing room only, to talk about the soil health resolution. So my last 2 slides are this. We need to come together, encourage our member states to put forth this soil health resolution. Please put your name in the chat, reach out to me so we can sign you up. What is the resolution? Recognize that soils are the basis of life and that soil health is the foundation of regenerative food systems. Affirm that agricultural, and that includes rangeland, systems are part of the climate solution. Stress the importance of aligning these UN conventions. Why do we have these separate conventions if we're all together? We need to consider the critical role of increased soil health to achieve ecosystem and reaffirm the need for international and local action to reverse current land degradation. So please, we'll share you the resolution, continue raising awareness, and let's all do our part. Thank you, Seth.
Lee, thank you. How about, let's get a standing ovation for all of our speakers. Applause. Yes, type applause in the chat. Look, if you look in the chat, you see people are saying applause, and yes, that's what I want to see. Type applause and yes there in the chat. Wow, how about that? Here's a glass of champagne for everyone. We had over 100 attendees right now, and there was about 130 at one point. Thank you, everyone. What a great sort of precedent-setting event as well. It's 1:15. We got a full 15 minutes left, This is a 90-minute event. So I would like to turn the floor over to the presenters and just sort of give them the opportunity to ask each other questions, or to ask me a question, or just to continue to go on a little bit for each other, as well as if you see a question via chat or the Q&A window that you think raises to the level of you want to talk about that specifically. So the floor is sort of open right now to either Dr. Johnson, Lee, or Precious. If there's anything else you want to say or ask, please just do so.
Well, I'm still working on the ones in the chat, so and they're all important. I don't know that another 10 more minutes is really going to cover them.
Dr. Johnson, well, let me ask you a question then as a follow-up. In terms of the science, I mean, the science that you just laid out was so profound. Put that in the context of what Precious and Lee are doing. There's Precious on the ground with communities in, Zimbabwe, Zambia. Here's Lee on the ground taking these measurements, working with the government of Kenya, as well as these international agencies. What's your vision of how you'd like this all to sort of move forward?
Well, I think we're finally coming around to seeing that nature has a better way, and starting to be able to look at soil biology in the first place. That's been a limitation, to really be able to track what's going on in the soil microbiome. And when it's the foundation of all of this. And, I think both Leanne and Precious are both seeing exactly what I'm seeing, that as you start to work or mimic nature and use the techniques that nature uses, that these soils can be reclaimed, restored, regenerated. There's so much potential that's sitting there. As I said in the presentation, it's regrettable that we focus just on soil carbon. It's more than just soil carbon. It's regenerating the photosynthetic capacity of these systems. If we don't capture it in the first place, you're not going to be able to increase soil carbon. You have to have a system that can capture that energy first. And then it's what happens to it from that point. Does it go, when it goes into the plant feeding the microbes in the soil, as I said, you get that positive feedback loop. Year after year after year, you see increases in productivity. We started on some soils, we were seeing 25 to 50 grams of dry biomass per square meter production. And once we started inoculation, we saw a year by year by year increase. That in the final year, we had increased about 20 times what that soil was capable of doing by getting the biology back in there.
Dr. Johnson, another real quick question for you, and then I see Lee has her hand up. Have you ever worked in Africa?
No. We do get a lot of questions from Africa, and we see that this approach, this BEAM approach, the composting bioreactors is in 60 countries across the planet. So, seems like you have to kickstart these systems. As you have allowed them to degrade, you start to lose species of microbes in the system that you can't replace just by growing another crop. We see the inoculation kickstarts the system. If you can look at that one video by Corey Miller that I put in there, you can see the influence of bringing the microbes back. He saw a 5 times increase in his cereal rye production in one season.
Yeah, and what I love about what you all are doing is it's so low tech. It's so low tech. I mean, it's really can't be more low tech than this, and the results are profound. So, Dr. Johnson, let's figure out a way to get you to Africa at some point, okay, so you can work with Lee in Kenya and Tanzania. Let me go to Lee now because your hand was up. Go ahead.
Yeah,
Lee.
I just wanted to address the point about biological indicators. And I think it's really important. And I think what we've been trying to do now is increase the scale of these biological indicators. So what we look at in the LDSF is earthworm presence. We look at arbuscular mycorrhizal spores, and we look at bacteria-fungi ratio. Now, let me tell you something. We've been doing AMF spores, but I didn't present it here because I knew Dr. Johnson was presenting. We look at two things. We look at diversity and size. And we say that bigger spores, you know, can help transfer nutrients more efficiently. What we're seeing in some of these degraded systems is low diversity and small spores. And so there's a real need to, you know, work on improving the soil biology, because we all know, and I see Elaine Ingham is here, maybe she can unmute herself. I don't know if she can, or promote her to a panelist, because on her podcast, what does she say to us all the time? Carbon is biologically mediated, and it goes through the microbes and all of these organisms, not 10 times, not 100 times, but thousands of times. And that's why I think it is really important that we figure out, and what we're trying to do is to scale these biological measurements across landscapes, and to really understand. Great, I can only say, you know, to really understand how management is influencing the different properties of soil, physical, chemical, and biological. Thanks, Seth.
Thank you, Lee. And yes, I saw that Elaine Ingham was here, and her and I have already done some back chat. Elaine, if you want to come in at some point, you're more than welcome to. I would love to get to some questions from the attendees. I think what we're going to do is there's a feature called Allow to Talk. So Debbie Young, I'm going to set you for Allow to Talk, and you can now ask the question to the attendees. I mean, to the panelists. Go ahead. Oh, so you have to unmute. So Debbie Young, you need to unmute. Okay, let me go to Pleasant. You have your hand up. I'm allowing you to talk, and you will also need to unmute. And I'm still just learning how to, sort of host these things. Debbie or Pleasant, you can ask a question if you want. Okay. Well, anyway, you're live now, so if you figure out how to unmute, you're welcome to ask a question. Elaine, you are free to. I'm going to elevate you. Let me figure this out. Elaine Ingham. I just promoted you to be a panelist, I think. So we're still just learning how to do this in real time. Yes. So Elaine, you can unmute and you can make a statement. There you go.
Yep.
There you go.
I just really appreciate all of the speakers today, because it so ties in with exactly what we've been seeing. It's the biology that drives the system, and we've got to get away from thinking about the soil as being these kind of inert chemical stations, and they just magically fix nitrogen. No, you have to have the biology in the system to do that work in order to start my video. Okay, one more thing. Other things to touch. We have to understand that it is a living system, and we've got quite a bit of upstream paddling to do with a lot of the people who have viewed soil as an inert material. Whereas if you really want to understand it well, you've got to understand it's all about the biology.
If anyone has questions for Elaine, she was an unexpected entry here. Feel free to ask her a question, I guess. That's what you get for showing up.
I don't mind. I love answering questions.
Yeah.
And I love David's work where he's showing how fungal to bacterial biomass ratios are very important, and how the predators in the system are very important. There, Lee, when you were talking about how important the living components are, exactly right on. I just would like to say to you that it's fungal to bacterial biomass ratios, not bacteria to fungi. So it's because I'm a mycologist at heart, I think. And so fungi come first. And those pesky bacteria, there's just a gazillion in there. They're always there. They're always present unless you are playing with dirt. No biology. That's not soil. That's dirt. So yeah, cool.
Yeah.
Let's work together.
Elaine, thank you so much for being here. In the few minutes we have left, I'm going to try to take another question from the attendee. So Nick, you will be next. I'm going to allow you to talk, and you'll have to unmute yourself. But just right before you do, I just want to say that Lee and Precious and I were all just at Sharm el-Sheikh in Egypt at the climate conference there, and it's just sort of a couple points. One is that that's sort of a desert, and I just couldn't help thinking it doesn't have to be a desert. That area can be greened, and next year's climate conference is in Dubai, in the United Arab Emirates, and I really feel like this should be an opportunity for us to talk about reversal of desertification, if you will. And also the other theme is just as sort of Africa. I mean, this was technically billed as an African COP. Some people don't think of Egypt as being part of Africa, but whatever. The point is, Africa is sort of seen, as the victim here, and in many ways, of course, they are. But they could also be a leader, and we need to transform how we think about, who's the leader and who's the victim, and if just in the future, if we could start getting the world to realize that places like Kenya and Tanzania can actually be the places that offer hope and have what we can learn from that's applicable to Europe and the United States, and Central Asia, that to me would be a really powerful takeaway. All right, that was just my little gestalt on that. Okay, so Nick, I'm going to allow you to talk. So you have to unmute yourself, and you could kind of ask the last question, I guess.
Wonderful. Can everyone hear me?
Yeah, we hear you. Very good.
Excellent. Thank you. It's an honor. Thanks for convening this great panel. My question is around vermifuge and macroarthropod processor, larval macroarthropod processors especially. Can or should we be reintroducing them in places where they've been broadly extirpated? And are there natural ways of dealing with parasites in our stock? Because I find when I'm approaching these questions, I'm lost for answers. Thank you so much.
Yeah, this is clearly a livestock question, right? Okay, David, take it away. Thank you, Nick.
There are plants. The plantain family is a dewormer for cattle. What you have to do is stop using the different, like ivermectin, in your cattle. That kills the community, the dung beetles. And you also have to select your cattle for your area. That's another thing that a lot of grazers do not really focus on, but the really successful ones, pick the right cow for the right area. And it's all in context, but they will come back. That's their nature. If you just rebuild the soil, number one, and stop using the all the chemical wormers. That's what we've seen, at least. You know, Alejandro Carrillo and Gabe Brown, Will Harris, all of them are observing the same thing. Alan Williams as well, as you back off of using the dewormers. And it takes a few years. It takes about 3 years. Watch the cattle you buy as well at the market that you're going to be putting onto your fields. If they've had a dewormer, then they can also do harm to your fields.
Dr. Johnson, I have to thank you for fielding that question, because I'll tell you the truth, I didn't understand a single word of what he was talking about. I was like, wow, that's over my head. And you know, and it wasn't until the end where I realized, wait a minute, this is a livestock question. I had no idea. All right, listen, it is technically 1:31. We like to stop on time. It seems a shame because we're all having so much fun. But I do want to kind of hold it to that. So thank you to all the speakers and to the conversation that just got started. And you know what this means, of course, is we just need to do more of them. Okay, and so we'll make that happen. The chat is saved automatically. The Zoom is being recorded in the cloud. We'll put that on YouTube. Some people were asking about the URLs that you were posting, David, in your presentation. Apparently, some of them didn't work or something to that effect. At any rate, let's make sure that all of the YouTube URLs that are in your presentation, we can create a separate file of those. Okay. And I'll do that. As far as the question and answer thing, I don't know if that is saved. I don't know.
You can save it and send it. That would be helpful. So
it would be. I don't know. I'll do the best. Moving forward, the Soil4Climate Facebook group is where sort of our activity is. The 4p1000 organization has great stuff going on. Follow them. Livelihoods organization, World Agroforestry, is a major sort of international NGO. Follow them. I believe Dr. Ingham is just sort of has her own space. Dr. Johnson has his own space. And let's all just stay in touch. Is there anything else we need to say before closing?
Thank you for the opportunity. Do appreciate it to get this data out there.
Yes, and then the slides will be shared with me, and we'll create a a folder with those if people are comfortable sharing slides. Anything else, Lee or Precious? Any other last message?
Yeah, just that we all have a responsibility, no matter where we are or what our expertise are, to really build healthy ecosystems, whether it's in the policy sphere, science, management. So really, we all can do something to improve soil health, rangeland health, and more productive, healthy systems. Thank you.
Precious, did you have any last words?
Yes, just to say thank you so much for the opportunity to talk to the world, and congratulations to everyone who's doing whatever they're doing to be on track ecologically. Really, thank you so much, and season's greetings, everyone.
Okay. All right, well, I'm going to end the session now. Okay, thank you, everyone. Love you. Stay in touch.
Thank you very much.
Thank you.
Thank you.